Connect the data cable between the L7 flight controller and the computer. Wait for the buzzer to sound. Select the correct COM port and click Connect. Click Setup. Select the second option. Select the Heli Setup option. Look at the throttle settings page. Find the option External Motor Governor Setpoint, since we are about to set the tail gyro gain. If the motor idle speed is too high, it may cause the tail rotor blade to separate blade strike. Therefore, we need to reduce this value. It is recommended to set this value just slightly higher than the critical rotor speed value. After setting, install the tail rotor blades and check that they are firmly attached. Also, straighten the tail rotor blades. Disconnect the USB cable. Secure the 26S batteries onto the helicopter. Flip all switches on the remote control to the upward position. Power on the remote control. Connect the 26S batteries in series to form a 12S battery. Then power on the helicopter. Wait for the aircraft to complete its self-check. Switch to 6G mode. Stay away from the tail area. Start the helicopter and test whether the tail holds locks. If there is a tendency to lock, the gyro gain direction is correct. Grab the tail and swing it left and right. The tail should self-correct. Now start the test. Unlock the remote control, flip the start switch, and hold the tail. When you swing the tail rotor rearward, the tail rotor self-adjusts and blows air toward the rear. Swinging the tail rearward creates a resistance. The gyro gain direction is correct. This helicopter uses the tail servo to control the tail rotor yaw control. The main rotor power is transmitted to the tail rotor via a shaft drive. The tail rotor thrust and direction are controlled by the tail servo moving the pitch slider, changing the blade pitch. For example, the tail rotor pitch state as shown in the figure. When the main rotor rotates, it drives the tail rotor. The airflow direction is rearward as shown. The state of the tail rotor is as shown in the figure. Its airflow direction is forward, as shown in the figure. The further the slider moves to the left, the greater the thrust. That is the working principle. How to judge whether the thrust direction is correct? Generally, start the helicopter. Grab the tail and swing it left, right. Carefully observe the gyro correction and self-adjustment direction. Usually, the slider moves in the opposite direction to the tail swing. However, some helicopters are different. It depends on the specific helicopter type. Now a demonstration. Unlock the remote control and start the helicopter. When we swing the tail rearward, its airflow blows rearward, and the airflow becomes stronger. This locks the tail and prevents it from swinging rearward. The gyro gain direction is correct. When the helicopter is locked, grabbing the tail and swinging it results in very small movement of the slider. This is correct. Only when the helicopter is unlocked and the motor is started can its tail lock function be demonstrated.